Hello, ME452. This is Evan speaking for Team 4, and I am here to give you an update on what Amelia, Assad, Gihan, Jason, and I have been up to with our project. So, as you can see from this lovely rendering over here that we borrowed from GrabCAD, we chose a Breville espresso machine as our product of choice to redesign for manufacturing and assembly for this class. And yeah, these machines are used all over the place, really. Homes, coffee shops, if you're fancy enough, you have one in your office or business. Yeah, they're a lot different than normal coffee makers. They take pressurized hot water and pour it over very finely ground coffee beans. And out comes just an ounce and a half of very strong coffee called espresso. I'll grab my handy dandy laser pointer, point out some of the major components here. We got a bean hopper, water reservoir, which holds the beans in water, control panel to control the machine. This controls the steam from your steam wand. Steam wand allows you to take steam from the boiler and run it through here to heat up milk for a latte. And you got the tamper here, which allows you to take the portafilter over and tamp the espresso before you attach it to the machine to have the water come over and run through your coffee. Here is an exploded view of the initial CAD that we borrowed from GrabCAD. So yes, you can see got the water reservoir over here. That's one of the main components. Boiler is over here. Let's see what else we got here. All sorts of lovely stuff. The bean hopper is an important part. That's right here. So yeah, lots of options for redesign here. Here we have our consumer groups, the primary of which will be adults, 35 to 60 for use in their home, a little bit older age range for the price range. Secondary groups will be smaller office spaces, hair salons, that kind of thing, so they can make their customers and employees delicious espresso. And here we have our fast diagram, where the task function is to, of course, brew espresso. So there's three primary basic functions there listed. You can see there's pressurizing water, grinding beans, and heating the water. You pressurize the water by first getting water into the system, pouring water, then increasing the pressure, grind the beans by storing the beans, and then rotating them. Heat the water by storing the water and then adding heat. We need to assure dependability of the system by controlling the temperature and preventing burns to our users. We do that by maintaining control and guiding the pouring of the espresso. We also have to assure that it's convenient by making the settings adjustable and allowing hands-free operation of the machine. We enhance the product by controlling the pressure, frothing the milk, and brewing the espresso quickly. Finally, we need to please the senses by adding a variety of colors and including accessories. So here we have two proposed assembly sequences for the products. Each of them begins with the lower shell and the water reservoir. In assembly B, the two sub-assemblies of the bean grinder and front panel are assembled at the start of production. Then it moves on to assemble the larger components, such as the boiler, thermal block, and coffee drip tray. Assembly sequence A attaches the larger parts towards the beginning of the assembly, beginning with the pump, thermal block, and recessed panels. Then it moves on to attach the grinder subassembly, coffee drip tray, and finally the front panel subassembly and cup warming tray. And as you can see by our assembly sequence analysis here, sequence B proves better for transferring and handling, as it starts with smaller parts in each subassembly and continues to assemble larger parts later on. The ease of locating parts for assembly B also scored higher for that reason. Ease of fastening and joining scored higher for assembly A because the top-down assembly left the espresso maker open and easily accessible to tools and hands. The ease of assembling in parallel was the same for both assembly sequences because they each contain two sub-assemblies. And here we have our bill of materials. In order to analyze the impact of any future changes will have on the cost of production, a preliminary bill of materials has been assembled to provide a rough estimation of the current manufacturing costs. Estimates were made based on the component geometry and likely manufacturing processes. Fasteners and more complex components, such as the pressurized pump and boiler, were assumed to be sourced from third parties, and estimates of their bulk purchasing prices have been used instead. The coffee machine that our model is based on typically retails for $700, so the estimated cost makes up for about 26% of the retail price. And here we have our function component mapping matrix. This matrix relates the components listed in the bill of materials to the basic functions listed at the end of the FAST diagram. We see a difference between components that serve one purpose and those that serve multiple functions. For example, the lower shell is used only to add colors, while the front panel helps to control temperature, adjust the settings, and include accessories. Having multiple components that serve the same function tells us the importance of each function. Here we have a couple options for potential redesigns. This first slide is the original hopper versus the commercial hopper. And these guys here are the water reservoirs. Again, both the consumer and commercial versions. And with this chart, we show which functions are different for the two customer groups. So mostly they stay the same, but storing the beans and storing the water is different for each group because we want to store more of them for the commercial version. And resulting from those two different functions, we have two different modules for our product family design. Both the water reservoir and the grinding cradle will be different depending on the model, and the rest will remain as platforms to the product. And here we show Assembly B's product family assembly sequence. As you can see, they are differentiated right at the beginning, which is not ideal. And of course, to improve that assembly sequence, we simply take our modules and assemble them at the end of our assembly sequence as shown in this chart. You can see the water reservoir and grinding cradle are all the way at the end. That's all for Team 4. Thank you so much. Bye-bye.